Fresh Kid Z, Fresh Kid C, yes, sir. Fresh Kid P, Fresh Kid T. Oh yeah, we back. Oh, and Zafoon, by the way. Yeah, Jones. Yeah. Chitty bang, and we pretty much amazing.
Back here with Ian, and we decided to go on a little adventure, so we're not really sure what to come, but stay tuned in.
Want the bread we can toast, so fresh how we flow. Everybody get this down from us. Was a kid with the other little kids, now I'm ripping up shows and them fans going wild with us. Tell mommy I'm sorry, this life is a party. Remember you was a kid, reminisce.
The first real snowboard was designed in the 1960s by a man named Sherman Poppins Murphy. It was a weird crossover between a plywood sled and a skateboard deck, and there was a rope attached to the front of the board that offered some control, and steel tacks poking through the upper deck held the rider's feet in place. During that time, snowboarding appealed to small groups of surfers, skateboarders, and backcountry enthusiasts. They were highly frowned upon by the majority of skiers, and they were not even allowed to ride regular slopes that were used for skiing. As snowboarding became more popular in the 70s and 80s, snowboarding pioneers such as Dmitry Milovashchik and East Coast surfer Jake Burton Carpenter came up with new snowboard designs, materials, and machines that slowly developed into snowboards, bindings, and other equipment we know nowadays.
So, how'd you guys get into snowboarding?
Me and Tavis met first in like 2001. The bar.
In a bar. We made a bet. I bet Ian that he couldn't snowboard down a hill without falling. Sure enough, I was right. He couldn't. He still can't do it.
No. I see.
But that's okay. I still love him.
So, how long have you guys been snowboarding, boys?
A long time.
I counted my fingers, probably 2 years.
Maybe 4? I don't know.
Maybe 4. If you count the thumbs and fingers.
Yeah.
Alright. Yeah.
Linear motion. A snowboarder typically gains speed by converting potential energy into kinetic energy of motion. So the more a snowboarder descends down a hill, the faster he goes. Projectile motion. When a snowboarder leaves a jump or a rail, the only force acting on the snowboarder is gravity. Friction. To prevent himself from going too fast, a snowboarder will skid his board on the snow in a controlled zigzag pattern. This creates frictional resistance of the snow and prevents the speed from reaching too high.
What happened, Ian?
Nothing went right.
Can you relate your fall to physics?
Yeah. Newton's whatever law of gravity sucks. If it weren't for that, probably would have just floated away like a majestic horse. It would have been fine.
The snowboarder with the greater mass will have a greater momentum. However, a snowboarder that is moving at a constant velocity as opposed to one that isn't moving at all will be the one with more momentum. The more force that is placed on the board and the greater displacement will create the most work. The faster the snowboarder completes the work, the more power it has. And finally, when a snowboarder is at the top of the hill, he will have the most potential energy, and as he goes down the hill, his potential energy is converted into kinetic energy.
So Eric, tell me, how did you get into snowboarding?
My friends, they took me.
How long have you been snowboarding for?
6 years-ish.
Are you any good?
Nope.
What is your favorite thing to do when you're snowboarding?
A 50-50.
Which is?
When you ride on the snow fast.
Have you ever won any awards for snowboarding?
I got best 50-50 on the snow.
Nice. What about you, guy with the mask?
No.
You've never won any awards?
I won biggest snaff award once, but that was about it.
In Newton's first law, a snowboard in motion will remain in motion unless acted upon by an outside force. In Newton's second law, a snowboarder with a greater mass and acceleration will have the biggest force. Newton's third law states that as a board pushes on the rail will push back on the board with an equal and opposite force.
So, could you guys tell me how snowboarding is related to hang time?
You catch sick air. Gnarly. Brah.
Thanks. Can you explain to me how inertia is involved in snowboarding?
Well, when you're at the top of the hill, there's an opposing force. I don't know. I already forgot. Alright. An object at rest stays at rest unless the friction lessens when I go down the hill. Alright? And that is how inertia relates to snowboarding, I think.
For our experiment, we tested the snowboarders hitting the rail at different angles. After testing our hypothesis, we discovered that we were incorrect, and in fact hitting the rail straight on produces the cleanest landing opposed to switch frontside because he landed close to perfectly and there was no snow that flew up on either side.
So, Ian, you're in chemistry, right?
Yes.
So you don't really know much about physics.
Nope. But Miss E loves me, so it's okay.
Do you have anything you want to say to Miss Ellingson?
No. No.
Hi, Tavis.
Hi, Alex.
How's your night going so far?
Amazing.
Any new tricks or anything
Yes, 2.
you want to explain?
I did switch front board, so that means I'm going backwards of what I normally would, and I slide on the rail with my back facing down the hill. And I did back 270 out, so I come onto the rail, and I go sideways on it, and I spin 270 degrees and land off the rail.
Wow, that's impressive. So, can you explain how any of that could relate to physics?
Well, I guess as I'm sliding on the rail, I'm pushing down on the rail, and then the rail's pushing with an equal force back up on my board.
And do you know what that's called?
Newton's third law.
Thank you. That was impressive. Well, we're on our way home. It was a good run. And I hope you enjoyed our video because we put a lot of effort into it.